Right, welcome back. I'm going to try and build this JYETech oscilloscope in one session if I possibly can. And just first of all, got to work out what all the documentation is. Well, that's the instruction on how to use it, but that's no use until we actually constructed it. What have we got here? This is the circuit board layout and parts list, and yeah, how to install resistors. Pay attention to orientation of components. I see there. That's all right. That's fine. We don't need to worry about that too much. That's fine. And then the main one is, I think, the instructions to construct it. So, got soldering hints and all the rest of it here. I've got to say, I'm pretty impressed with the quality of the literature that's come with it. That's not bad at all. I am wondering how much of this I really need to worry about. Because we have got a printed circuit board that has got most of the components marked on it, fairly straightforward. But I'll tell you what, let's follow the instructions. Let's get that out of the way as much as we possibly can to minimise cock-ups. So yeah, let's get going. So step one, main board and LCD board. Now what I might do through this, I'm a little bit undecided whether I'm just going to leave the camera running while I'm building this, and then perhaps do a bit of a time lapse when I edit the video, so that you're not listening to me ramble on, but you can see basically what's going on with the build. Yeah, that might be the way forward, and what I'll do is I'll put it back to normal speed if there's something interesting to talk about. But there's quite a few components here actually. I don't realise just how many there are. There's even a LED there as well. So yeah, we shall have a look at that. I think really just the main thing with constructing this, if you're not really hot on electronics, which I'm not, is to understand things like orientation of components. So for example, you've got a transistor there. The transistor it's got 3 pins, base, emitter and collector, and really all you need to do is make sure that you've got the pins in the right holes. And one of the ways with doing this, you can see that it's got a flat edge on one side, and probably on the PCB, I haven't checked that this is actually the correct location for it, but if you look here, that may very well be the slot for a transistor, and you see it's got the flat edge there, so you just have to match it up, stuff like that. Fairly straightforward. But the first thing to do is the resistors. So it's actually saying here, always meter resistor values before soldering. Probably no bad idea. It's not actually telling me the locations and values, so this, I guess, is where I think, frankly, this is going to be a lot more useful than that. Now, I thought that somewhere it does actually stop during the assembly, or stop you during the assembly to test it. But if it does, I'm not entirely sure where. Because most of this is, yeah, we'll see down here, you've got the voltage references. So at those test points, it tells you what the relative voltages should be. But of course, that looks like after it's been constructed, not before. or rather during construction. So what I'm basically saying is it might be that you construct so many components and then you test voltage to make sure that you've got it right. But I don't think it does anything like that. So, right, let's crack on. Okay, well, generally speaking, with these things, what I'm going to do is I'm going to first of all sort out all the components and put them in piles of like components. Right, well, that's the surface mount components completed. As I went through the list, you can see that this is the English language side. On the other side is the Chinese language, and just to prove how easy it is, I didn't even bother reading the English and didn't realise that I was working with the Chinese side, but I just went through each component and ticked them off as I installed them to make sure that I'd got the right component in the right location. The locations are very easy to find on the board. Let's have a quick look at the let's see if I can show you through. It might be easier through the magnifier, I don't know whether this will work or not. We'll have a look. But yeah, so you can see all the surface mounts on there. The resistors are smaller than a piece of or a grain of rice. That's how tiny they are. But tweezers and a little patience, and you're good to go, really. Yeah, so no problems. Right, so that's the surface mounts. The next thing to do is to consider the through-hole components, which is all that's left. Probably the resistors next. So I'll hook all of those out. You can see I've got all the components laid out around the place here, just to keep order of everything. So the hardware, caps, resistors and so on, all the rest of it's installed. You do actually get spare surface mount resistors, because they are so tiny. I guess lots of people do lose them, but it really depends on which ones. I mean, I've only got one of that value left, and that was what, the 1k, so I had a fair few 1ks and 1.5k. How many of those I've got left? Just one of them. But if you do lose one, then all is not necessarily lost. You may very well be able to have enough there to make sure that you have all you need to complete the kit. So with that, I'm going to start organising myself on the next set of components. Okay, looking at this sheet, we've got a list of all the resistors and their locations, and there's a fair few of them there. Now, soldering in resistors is hardly exciting, and neither is soldering in capacitors, but we'll do the capacitors and the resistors off camera because they're straightforward enough. Then the polarity doesn't matter which way round they go. The most important thing is to make sure that you get them in the right location on the board. So we know that R1, R14 and R16 are 100k, and we need to pull out all the 100k resistors from here. So the most important thing is that if you do have a meter, that you test them to make sure that you're using the right value resistor for that particular location. If you don't have a meter, then what you can do is you can go online and just Google something like resistor values, and with each colour code you can enter the colour code of the resistor by just sort of, I don't think this is going to focus, is it? Going to focus? Probably not. But there's coloured bands on each resistor, and you can just enter those colours onto the online calculators. There's several of them on there, and it will tell you what their values are, so you know which resistor needs to go into which location. The capacitors are marked with a number, and well, we'll have a look at those a little bit more closely, but that'll be, for example, that number 1 there will be 1 picofarad. The 104 I'm guessing will be, I'm not sure what 104 is, I can't remember. Again, you can look all this stuff up online and it will tell you what the values are, just to make sure you get the right one. So anyway, as I say, they're straightforward enough through-hole components. So what I'm going to do is I'm going to install all of those onto the board, and once I've done that, I'll get back to you as to where we are. Right, okay, that's the resistors installed. Every single one of them I tested with my meter. But as I'll talk about this meter, it's a fairly new acquisition. I've had some very, very old meters and never quite trusted their results, but this was a really cheap one I got off of Amazon, and seemed to be quite well rated and liked by previous buyers, so we went for it. But that's a topic for another discussion. So all the resistors are in now. We've got all the surface mounts on, and also there's 1, 2, 3 inductors to install as well. And as I've been going through, you can see what I've been doing is just ticking off the parts as I've used them, and that lets me know exactly where I'm going. The only problem I've got is this one is resistor 2 is supposed to be 1.8 mega ohms, and I measured it as 1 mega ohm, so I don't know if I'm going to have a problem there or not. That's a bit odd, but I had exactly the right number of resistors, so unless there's nothing else of the value of 1 mega ohm that I could see, so I don't think I've screwed up by putting a resistor or swapping them in the wrong places. But yeah, that's a bit strange. It was certainly reading as 1 mega ohm, and not 1.8. So I don't know what was going on there. Any road up, so that's that. And the 3 inductors, put those in as well. And the next thing to do is diodes. Then we put in the crystal, then the USB socket, the switches, ceramic caps, LED, and then over the page, pin headers, transistors, regulator, caps or capacitor trimmers, power inductor, electrolytic caps, power connector, another pin header, and then these larger pin headers, and the slide switches, and finally the BNC connector. Now all of this stuff is through hole, so it's all very, very straightforward. I'm not going to finish it now. I think this might be a job for another day, because it's getting quite late now. So what I'm going to do is I think I'm going to finish this video here, and we'll treat this as part 2, and hopefully do part 3, which will be the remainder of the build at some point in the future, not too distant future as well, because I want to get this one done, because I've got some other kits waiting to go over in the corner there, and I've even got a few more smaller ones on order, so plenty to make and do. So with that, I'm going to say thanks for watching, and we'll see you again very shortly with the remainder of this build. Cheers for now.